So let us graph the second example, which is the graph of a cotangent function. So I am going to get started with writing the transformations. So the transformations are going to be a horizontal stretch by a scale factor of 2. So let's go ahead and figure out what our period will be. So to find the period, we are going to do pi divided by the absolute value of b. So in other case, it's going to be, in our case, it's going to be pi divided by the absolute value of 1/2. So the period of this function is going to be 2 pi. So let's go ahead and get started with our x and y values. So we know that a cotangent function will have its vertical asymptote at the y-axis, which is going to be our x equals 0 point. So this is where it's going to be undefined. And then we also know that the end of the period is going to be 2 pi, and here it's also going to be undefined. We know that the halfway point between 0 and 2 pi is going to be pi, and that's where we have our x-intercept. We also know that the graph is going to be a decreasing graph. Therefore, at the halfway point between 0 and pi, which is pi over 2, we are going to have a positive value. And the halfway point between pi and 2 pi, which is 3 pi over 2, we are going to have a -1 value. In this case, we don't have a vertical stretch or a vertical shrink. So let's go ahead and write this here, 1/2 times pi. And then here we have halfway between pi and 2 pi. So I could do pi plus 2 pi divided by 2, and that's what gives me the 3 pi over 2. So let's go ahead and graph our vertical asymptotes first. So we know that we'll have a vertical asymptote at x equals 0. So these are going to be my asympts. And then we also are going to have an asymptote over here, which is going to be x equals 2 pi. X equals 2 pi. So in between we have pi, and we have pi over 2, and then we have 3 pi over 2, and here was our 2 pi. So now we are going to have to create our graph. Here is our 1 and our -1 value. So at pi over 2 we'll have 1. At pi we have 0, and at 3 pi over 2 we have -1. So we are going to create the decreasing graph, making it a curve for the cotangent function. So we know that the domain is going to be all real numbers except x cannot equal to 0 and x cannot equal to 2 pi in our case, and the range is going to be all real numbers. We also know that this graph is going to be decreasing throughout the entire graph. The next 4 slides will be your monitoring progress problems, so please go ahead and work them out on your lesson notes before you move on to check your answers. although on this graph you can see that it kind of looks like they're lines, they are still curves. So please don't forget that tangent and cotangent graphs are curves. Similarly, on this one, the tangent graphs are curves. However, they appear to be lines, almost lines, because there is a vertical stretch of 5. So please make sure that these are curves and they are going to be graphed between those asymptotes. Core concept, the characteristics of graphing y equals secant x and y equals cosecant x. You remember that secant x is the reciprocal of the cosine function and cosecant x is the reciprocal of the sine function. So the functions secant x and cosecant x have the following characteristics. The domain of y equals secant x is all real numbers except multiples of pi over 2. At these x values, the graph has vertical asymptotes. The domain of y equals cosecant x is all real numbers except multiples of pi. At these values, the graph has vertical asymptotes. The range of each function is y is going to be less than or equal to -1 and greater than or equal to 1. So the graphs do not have an amplitude, and the period of each graph is going to be 2 pi. So the graphs of the secant and cosecant functions are related to the parent functions of y equals secant x and cosecant x the way it's shown below. So if you look at the y equals secant x, it's the reciprocal function of cosine x. So if you're looking at the graph, first we are going to graph the cosine x, which is the reciprocal function. And wherever you see cosine is being 0, that's where you will have your asymptotes for your secant function. And then afterwards, we are just going to graph this cup-shaped function, which is going to be your secant function. You can see that the period is 2 pi because you have to have an upside down and a side up or opening up kind of a cup in the function to create the entire cosecant function. Similarly, for cosecant function, we are going to first graph its reciprocal function, which is the sine function, and we'll have our asymptotes where sine is 0. And again, the period is 2 pi because we are going to graph a cup up, opening up, and a cup opening downwards. It makes sense because the sine function is opposite over hypotenuse, and the hypotenuse is always the longest side. So that's the reason why in the sine function we have the range between -1 and 1. However, if we flip that fraction over, that's going to be 1 divided by a number less than 1. So all the values are going to be greater than 1. And the lowest point or the minimum point of the cup is going to be at the same point as the maximum point of your sine function for cosecant, of course. And then your maximum or minimum point of the sine function is going to be where the highest point of the cup is of your cosecant function. Similarly, in the cosine function, if you are graphing your cosine function, then the highest point of the cosine function will be the lowest point of the facing up cup of the secant function, and the lowest point of the cosine function will be the highest point of the facing down cup of the secant function. So when we look at this first example, we are talking about g of x equals 2 times secant x. So the transformation is going to be a vertical stretch by a scale factor of 2. And so again, as I said, we are going to graph the reciprocal function. So the reciprocal function of secant x is cosine x. So let's go ahead and graph first the y equals 2 times cosine x. So we are going to graph y equals 2 times cosine x. This is our reciprocal function because this is the one that is going to help us to graph our secant function. So x and y, and we are going to again start with 0 in the middle. We know that the period of the function is going to be 2 pi over the absolute value of b. Since our absolute value of b is 1, it's going to be 2 pi. So I'm going to place 2 pi here and negative 2 pi here. The halfway point is going to be pi, and a quarter point is pi over 2. 3/4 point is 3 pi over 2. And negative pi over 2, negative pi, and negative 3 pi over 2. So let's label our x-axis. So when we label our x-axis, we are going to say this is 0, this is pi over 2, that's pi, 3 pi over 2, and this is going to be 2 pi. And here is our negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And we are going to say that here is 2, and here is negative 2. We know the amplitude of the cosine function, the reciprocal function, is going to be 2. So here is our maximum point, our 0, our minimum point, our 0, and our maximum point of our cosine. Remember, cosine is going to be starting with its maximum point and going up to its maximum point. So here we have 1, 0, then here we have 0, 1, then negative 1, 0, and here we have 0, negative 1 as an ordered pair, and we know that the x coordinates are going to be our cosine values. So I'm going back to the graph, and then I'm going to connect these with a nice curve. And we are going to label this to be the reciprocal function, so it's y equals 2 times cosine of x. Now let's graph our asymptotes. So remember, the asymptotes appear where cosine is going to be 0. So the asymptotes of the secant function are going to be over here. And let's say these are our asymptotes. So it's x equals negative 3 pi over 2, x equals negative pi over 2, x equals pi over 2, and x equals 3 pi over 2. Once we have the asymptotes, it's easy to graph the secant function because all we need to do is graph those cups. So I'm going to start over here, and I'm going to make kind of a parabola shape. It's not exactly a parabola. Make sure you don't get past your asymptotes. So here is our secant function in blue. And I'm going to do this last one, but only half part of it. And then I'm going to do it here too, only a half part of it. So the blue graph is our g of x equals 2 times secant x. And then its domain is all real numbers except x cannot equal to negative 3 pi over 2, negative pi over 2, and then pi over 2 and 3 pi over 2. And the range is going to be negative infinity to negative 2. And the second part is from 2 to infinity. So let's graph a cosecant function also. So this cosecant function says 1/2 cosecant x pi times x. So the transformations are a vertical shrink by a scale factor of 1/2 and a horizontal shrink by a scale factor of 1 over pi. So let us also figure out what the period of the graph is going to be. So the period of the graph is going to be 2 pi divided by the absolute value of b. In our case, it's 2 pi divided by pi, so the period is going to be 2. So let us go ahead and put x and y, and then we are going to put 2, 0, and negative 2. And then obviously we'll graph the reciprocal function, which is y equals 1/2 sine pi x. So let's go ahead and figure out our in-between values. So the halfway point is 1, and the quarter point is 1/2. The 3/4 point is 3/2. And then it's negative 1/2, negative 1, negative 3/2. And we know that the sine function starts, again, if I make my unit circle, and I put 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The sine values are my y coordinates. So when I make the table of values, I make it for my reciprocal function. So here it's 0, then it's 1, 0, negative 1, 0. And if I go backwards, it's negative 1, 0, 1, 0. So let us graph our function here. First our 1/2 sine pi x function. So we are going to have a 1/2, 1, 3/2, and 2. And here's our 0, negative 1/2, negative 1, negative 3/2, and negative 2. And then let us make the graph here to be 1 and here to be negative 1. So let's graph our first our sine function, which is a 1/2 pi x. So that means we start on 0, 0, and then our amplitude of the sine function is a 1/2. So we are only going to go to the 1/2 point, and then we are going to go ahead and graph that in the other way too. So now let's get started making that nice curve. And we can label this as y equals 1/2 sine pi x. Now we are going to graph our asymptotes, which are going to cross the x-axis where sine is 0. So I'm going to make all my asymptotes, and then we are going to label them. So our asymptotes are going to be x equals -2, x equals -1, x equals 0, x equals 1, and x equals 2. We can also say that, or we can actually graph now our cosecant function. So let's go ahead and graph those nice cups. Here is where my up, and here is facing down and facing up and facing down. And again, make sure your cups are in between your asymptotes. So my blue graph here is that g of x equals 1/2 cosecant pi x. So let's write our domain. So our domain is all real numbers except x cannot equal to -2, -1, 0, 1, and 2. And the range is going to be from -∞ to -1/2, -1/2 included, and then from 1/2 to infinity. And so we just created our cosecant graph. The next problems are all your monitoring progress and your exit ticket problems, so please work out the solutions on your handout or printout, or work them out on a piece of paper before you look at your answers.